Hi guys, welcome back. So I'm really excited to announce this small mini course where we'll be building a real-time chat application with Golang for the backend and React for the frontend. So it's a full stack Golang application. We'll be using Socket to coordinate between frontend and backend for the real-time chat. And as you can see, I'm running two different servers. I'm running my Golang server for backend and my React server for frontend. And a lot of people have been requesting, right, for chat applications and for full stack applications. So this is a small course that I've created for the same. And I know the color scheme isn't the best here because I'm not the best at CSS. But obviously, once you complete the tutorial with me, you can take this code and you can change the CSS on your own to your liking. What I'll be focusing mostly is the logic. So building all these components, getting the chat to show up here and configuring the entire backend, all of the logic is what we'll be focusing on. So whatever chat you write, hey there, it'll start showing up in your chat history. And whenever a new user joins up, you'll see here, new user joined. So this is what we're building, right? A real-time chat application with Golang and React using Socket. So let's start looking at the structure. So we'll have our backend and we'll have three different files: our client file, pool, and Websocket, and our main file. And then on our front end, we'll have an API file that will be responsible in coordinating or talking to the backend and calling the APIs. And we'll have these three different components: chat history, chat input, and message. Right, as you can see, chat history, chat input, and the message itself. So these will be different components. And then we'll have our header and body and all of those different things. So in short, this is what it is, and it's not going to be a huge course, as in I think we'll be able to cover it in about 7-8 videos of about 10 minutes each. There's not a lot of code to be written, and I think it's going to be simple. But again, I'll say that you need to have some background with React. You can't you can't come completely empty, because this is not a React introduction course, right? So I'm assuming that you already know React, you already have built a couple of projects with React, and then this project will make sense to you. Similarly with Golang, you can't be coming completely empty-handed with Golang. So you need to know the basics of Golang. You need to know everything like structs, interfaces, slices, Go routines and channels, all of those different things. You have to know all of those things. If you don't know those, then you can just go to my channel and build a lot of the other simple projects that I've built, like building a simple server in Golang, building MySQL plus Golang project, and then those different scrapers that I've built. So once you go through those, you'll get your hands dirty. Then when you come to this, it'll make a lot more sense, right? You can't expect to understand Golang if you build a complete full stack project, right? That's not the way to learn. All right, so you need to know the basics of Golang. We'll actually start coding, and I'm in a place in my machine where I usually keep my Golang projects. So I'm using Linux here, but you could be using Windows or Mac, doesn't matter. The commands will be the same for the terminal at least. And so what we'll do now is we'll create a directory for the new project. We'll say Golang chat project, and we'll cd into it. And here we'll have to have two different folders created, one for the backend, one for the front end. So for the backend, which will have Golang, we'll say mkdir backend, and we'll cd into backend, and we'll say go mod init github.com/akhil/Golang chat. So our backend project is initialized. Now we'll go back to create the front end folder. We'll use create React app. So we'll say create. But before that, let me show you the Node.js version that I'm using. I'm using 15.5.0. I'm using this tool called NVM. It enables me to use multiple node versions at the same time in my computer, so it's very, very handy. If you don't know what NVM is, I highly recommend you check it out, because you might have different projects in your machine which are using different Node.js versions, right? So that's why I use NVM. Anyhow, so I'm using the latest version. I think it's the latest version, 15.5.0, not sure, but it's quite new. I know that much at least. So here what we'll do is we'll say create React app, and we'll call it front end. So it'll take a while. So what I'll do is I'll just pause this video and I'll come back so that I don't end up wasting your time. So the project has stopped building, and if I run ls in my project, directory, then I can see there's a folder called Frontend, and if I cd into Frontend, I can see it's a complete React application. All right. So now what we'll do is we'll start working with the front-end application, and so we'll I'll use VS Code. So I'm opening up the entire project in VS Code. You could be using any other code editor, not a problem. So you have your app.js here and your index.js here. Index.js, I don't think there's any need to make any changes. But app.js, what we'll do is we'll just remove whatever is there in app.js. And in our src folder, we'll have two different folders. One will be called API, and the other is called components. All right. So now what we'll do is we'll create 4 different components. One is chat history. So it's capital C, chat, and history. And then we'll have chat input. So regarding these components, I've already shown you in the diagram, I think, how they're supposed to work and what they are. One will be header, and the last will be the message component. Now inside all of these different folders, like chat history, there will be 2 files. One will be chat history.jsx, and the other will be chat history.scss. All right. For chat input as well, we'll have the same. So we'll say chat input.js, and we'll say chat input.scss. Similarly for header as well, header and message, the same things. So you'll have a file called header.jsx and header.scss. For the message as well, right. So we can start with the chat history component. Let me close down all the other files that are opened up here. So let's start with the chat history component. What we'll say here is we'll say import React, component from React, and we'll import chat history.scss into this file, and we'll import message from message. All right. And similarly, we'll go to the other folders also. Now one more file that's required for each of these folders is also the index file. So we'll have to create an index.js file in each of these folders. So we'll say index.js, which will be like the main controller file in each of these components project folders. So here also we'll say index.js. Here we'll say index.js. So in the index.js files will be very, very simple. There won't be much complication there. For example, in the chat history index.js file, all we're going to say is import chat history from chat history.jsx, and we'll just export default chat history. So this file just makes it easier for the other components to include the chat history component. All right. Now with the chat input index.js, let's do the same thing. So we'll say import chat input from chat input .jsx, and we'll export default chat input. So as you can see, we're following a very modular kind of a system format, right? Makes it easy to implement and easy to also process and keep track of. So for the header index.js, we'll say import header from header.jsx and export default header. Similarly for message, the message index.js, you'll do the same thing. You'll say import message from message.jsx and export default message. So far so good. Now what we can do is we can start with our message.jsx file. So we'll say the same thing here, import react comma component with C capital from react and import message.css. Alright, and I think what we'll do is we'll go ahead and add the same details for all of the other JSX components as well. Let me close out these other files, and here we have to say import react from react and import header.css. Then all we are left with is the chat input.jsx file. So we'll go to chat input. It was supposed to be JSX, sorry. So I'll rename it to be JSX. And let me check if everywhere else also have kept it as JSX. Yeah. So everywhere else it's okay. So the chat input.jsx file, you'll say import react comma component from react and import chat input css. Okay, so this component, actually the chat input component, is very easy and very straightforward. So I think what we'll do is we'll build this one first. So we'll say class chat input extends component, and we'll use a render function to return div class name chat input and there's only one thing here. It's just an input box. And when you press enter, it sends a prop. So props.send, and there's a placeholder text. Is just type a message to, which is just type a message and hit enter to send. So quite straightforward. So this is your chat input component. So what we've done is we've created the project, and we created our backend and frontend folders, and we have created these 4 different components. We have created these different files in every single component, and we have created the complete chat input component as well. So we'll start working on the SCSS and all the other components as well. And we also have to work on our app.js file. So now what we'll do is we'll work on our app.js file, and then we'll also work on our API folder. All right. So inside API folder, actually, we'll just create the file and keep. So it's called index.js, right? And so let's come back to the app.js file, and here let's start importing some stuff. So we'll say import React and component from React. So this is basic React stuff. So I'm not, I'm going a bit fast, but if you are having difficulties in understanding what I'm doing here, do feel free to put that in the comments below, and I'll try and help you out, and I'll try to explain to you what's happening. All right. So here we're just importing React and component from React, and we're just importing the header from components, and then we'll import chat history. The chat history component from components / chat history / chat history. So by default, this gets you the JSX file, right? This is header.jsx, this is chat history.jsx, and they're both in the chat history and header folders inside components folder, right? Components folder, chat history, and header folders, and these are the JSX files that we have imported out here. And we also need the chat input component from component / chat input / chat input. And then we'll also import the app.css file. And we'll import. So we'll create 2 different functions now. So one will be the connect function, the other will be the send message function, and they'll both be inside your index.js in the app API folder. So we'll say API for now. And here we'll start writing our app. So the component that we just imported here, we are using it out here to create our app. And here we'll say constructor props. This dot state. Let's initialize the state. So state is equal to. So in the beginning, chat history will obviously be null. There'll be nothing there. So it's an empty array for now. And when our component mounts, so we'll say component did mount. We'll use the connect method. So what I'll do now is I think I'll just create the connect method here. So let's go to your API and index. Let's work on this file actually. So let's say var socket. Let's create a socket, new web socket. New WebSocket, and let's create our connect. So connect is equal to console.log connecting, and if the socket opens, so we'll say socket.onOpen console.log successfully connected. So if the socket was open, you'll say successfully connected. If there's a message, if the socket receives a message, socket.onMessage. Now all these functions like on message, on open, you get access to them using socket, right, which you have defined here, which is basically a WebSocket. So if it receives a message, so all you have to do is console.log message from WebSocket, and we'll display the message out here. And then we'll have socket.onClose, socket.onClose. So we'll take the onClose event and we'll say console.log socket closed connection, and then we'll print out the event. And then we'll have, if there's an error, so we have the access to socket.onError property, and we'll capture the error here, and then we can say console.log socket error, comma error. And lastly, we will have our send message. So we'll say let send message is equal to message console.log sending message, comma message, and socket.send message. So we have two functions that we have defined now. One is the connect and one is send message. Send message just uses socket.send to send the message, and connect has provisions for all of these different properties that socket gives us, like on open when the connection is open, when a message is sent, when socket is closed, and when there's an error. All right, so all we have to do is we'll have to just export connect and send message from this file. So in our app.js, back in our app.js, we have to make use of these functions. So we'll say connect, and then here we have access to our message, and we'll say this dot set state. We'll take our previous state. Sorry, to take our previous state, we'll just wrap this in regular brackets and then curly braces. Actually, let me just create this whole thing again. So we'll say connect message, and here we'll have curly braces, and we'll say console.log new message, and after this we'll say this dot set state previous state, we will say chat history previous state dot chat history, comma message. So all that's happening here is that first you define a constructor, and then you take the state, you define the state. So the state has only one object, one value. It has the chat history, which is an array which is empty as of now. When a new message is received, right, you take this .set state function, and you get access to the previous state, and you take chat history which will now become equal to previous state, the chat history of the previous state, and the new message that came here. So it's going to be an addition of both of those things, right? All the messages that you had in the history and then the new message that came. That's the new state of chat history. Pretty straightforward. And then we'll also need to console out the state. So we'll say console.state, and we'll put a semicolon here. We can have our render function here, which just returns a div of class name is equal to app, and here you'll have your header component, you will have your chat history component with chat history is equal to this dot state dot chat history. You pass this as a props. So the chat history that you have access to here, you're passing it as props to this component here, right? And the props can be accessed using chat history. So we'll use this to access this chat history inside the chat history component when we'll work on it in some time. Then you have your chat input send is equal to this dot send, and you put a semicolon here. Here you can export default app. So we have worked on our app.js file and we have worked on our API file as well, and both of them are complete. We built the chat input component completely, and now we'll start focusing on our header component. All right, so here we'll say const header, and we'll use a functional component here, and we'll say div class name is equal to header, so we're using a functional component because this component doesn't do anything. It just returns an h2 tag with some text, like let's say go and React chat app. So that's it. So it's a very, very simple component. Now what we can do is we can work on the CSS a little bit. So we'll say dot header, and we'll say background color. So I've taken this color. You can, since I'm really bad at CSS and you could be better, you can select any other color that you want. Just give it a padding from everywhere, 50 pixels, just to make it. So the CSS that I'm doing is like bare minimum, the very basic bare minimum CSS that I can get away with. That's all I'm doing, because I don't know how to use CSS actually. So I'm sure you already know what CSS is and how you can use it much better than me, and you can feel free to change these things. All right. So I've been a React developer, I've been a Golang and Node.js developer, but CSS is something not learned, but probably I'll start learning it now. Like I know the basics, but like the advanced stuff, those things I don't know. But I'm planning to create a course on how to build let's say something like Facebook or something like that from scratch using React and then CSS. So I'll have to learn it. But anyhow, for now, I think this is quite possible for now. So our header component is complete along with the CSS. And last time we had done our chat input component, but we had not done the CSS for it. So let's quickly do some basic CSS here as well. So we'll say chat input margin auto, and the input tag itself, we'll give it a padding of 10 pixel. If you get bored by CSS, then you can skip this section completely, the CSS part, and you can I'll leave this code in GitHub, so you can just pick it up from there if you want. Border, like I'll leave the code after this series is complete. Once I complete this project, I'll leave that code in GitHub. It is 5 pixels, and then border 1 pixel solid. -5 pixel RGBA 0,0,0,0,1. All right, so we've given it a box shadow, we've defined the width, we've given the border and border radius, and basic stuff like font size and margin and padding, like very basic minimal stuff to at least make it a little bit presentable. So now I think what's left is our our message component and our chat history component. So let's start with the message component. So we'll say class message. Now we're creating our message component before our chat history component, because the chat history component is going to require the message component. So here we'll say extends component constructor props. Yeah, so it basically parses with JSON this.props.message, and we'll define a state also for this. The state will be message temporary. Let's make it temp. All right, so whatever props are coming here, we'll parse it and we'll store it as a state in a variable called message. Straightforward. And now we'll just run a render function. So we'll say render return semicolon here at the end. Just write export default message, and here we'll give it a class name message, this dot state dot message dot body. All right, so all that we're rendering here in this message component is this dot state, which is this dot message, and the message basically, which is temp, has a body that has been passed, right, as part of this props. So that's all that we are rendering here in this component. Quite straightforward. And now we'll start working. Let's actually work on the CSS for this, and then we'll move forward to our chat history component. CSS is going to be quite straightforward, so we'll say message and display block, background color #b to b1b9, margin is 10 pixel auto, and after margin we'll use some box shadow, 0, 5 pixels, 2 pixels, -5 pixels, and RGBA, 0, 0, 0.2, and some padding, 10 pixels and 20 pixels, and border radius 5 pixels and clear. And then some color 70, 28, 28, and float right, background color FFEDA3. So this is it. I mean, I know it's just not even 15 lines of CSS code, but this will basically, ensure that the project doesn't look complete, shit. I mean, there'll be at least a little bit of presentation there. So this is the bare minimum I could do to keep it from looking like complete shit, basically. So this is your CSS for the message component, and now all we have to do is work on our chat history component and the chat history CSS, and then probably a couple of more things, and then the front end is at least complete, and we can start working on the back end of this project. So we have built out a lot of components, and in this video we'll build out our chat history component and write some CSS for chat history, and then we're almost done with our front end, and we'll start working with backend from the next video onwards. So let's get started with the chat history component. So it'll be a class-based component. We'll say class chat history extends component render. So we'll first log out the props that we're getting here. So we'll say this dot props dot chat history, and then we'll take this dot props dot chat history, and we'll map over the props that we're receiving. So we'll say we'll use the message component, give it a key, message.timestamp. So we give a key usually to help sort out and display it one by one. That's why we give a key there. And then we get message.data. So message.data is what we want to display, and message component is the one that we want to use to display it. I want to close the component here, put a semicolon here. So all that chat history is doing is all the messages that have been written, those we are basically using the message component that we've already built to display them. And to map over them, we are giving it a key, which is basically timestamp, which is going to be unique. So any unique key works here. It can be a UUID or it can be a timestamp, right? So we basically first print out the chat history props sent to this component, then we map over them, use the message component give it a key for timestamp, and then we give it this props called message, and then we just print out message.data. Now this props called message is then taken into the message component, and then it makes a variable called temp that parses this props, right, and it sets it at message, and then we can access state.message.body, and then one by one all the messages will show up in the chat history. So I hope everything is clear. If things don't make sense, you can put that in the comments below and I'll help you sort them out. Since this front end is very, very straightforward, I'm not explaining it too much, but if you still have any issues, do let me know. And here we'll have class name is equal to chat history, and we just return h2 tag chat history, and then we return messages here using JSX. We put a semicolon here, and at the end we try to export default chat history to export the component. Alright, now let's start working on our CSS. The CSS is not even going to be like 9 lines, so it's going to be very, very straightforward, very, very simple. So the chat history class that we just defined in our component, we're going to use that to access chat history. We'll give it a background color. So I'm using this color to C2E43, but you could be using any other color. Margin is 0. Padding from all sides 20 pixels. And the h2 that we defined, we'll give it a margin of 0. Padding of 0, just resetting everything, and color will be white. Now I've given it like very, very simple and basic CSS to just make sure that the project is presentable, but you can go ahead and you can change the CSS and make it much more fancy, right? So I'm just focusing on React and Golang here instead of CSS, but you can go ahead and make it as fancy as you want. So our React project is almost over, I think, and now we'll start working on our backend. So here we left out one thing, so it's export default, which is basically this component in the chat input. So there's obviously like a chat history where you see all the previous chats input, where you'll input the chat, right? There's just a header and the message that you actually send. That's it. There's no React heavy React here. So then you have chat input. Okay, this is what I want to output, and there is this default app.css file that we get here with React, because we started a React project, right? So this is what we get. Now I want to get rid of it. So this is not important. So all we want here is just very basic background color for the body, and I want the margin and the padding to be 0. So I'll say 0, and I'll say padding to also be 0. Background color, I'll just take any random color. I'll just take let's take this one, 595 260. So I have the color palette open up in front of me. So I'm going to take this random color, put a hashtag here. Okay, so that is it. Now there is, okay, in the index.css, right? Come to your index.css. This is again the standard file that you get in the React app project. Here along with margin, I also want to make the padding 0. So as you can see, the Create React app project comes with a lot more CSS. So I even removed all of that, and I just put like basic margin padding 0. Everything is 0. No, I don't want anything fancy. I don't want anything to look fancy, right? Just a very crude React application. Okay. In case like, see, I'm sure everybody understands all these components and what I'm doing here. But in case you still are not following along, I'm going to be building basic React projects also on my YouTube channel, and I'll explain React to you from the basics up. Okay. But for now, just understand that React basically has components, and in my case, components are basically atomic individual elements that you bring together to create a React application. And then here, in my case, I'm just using chat history, input, header, and message. That's it. As you know, my expertise is the backend side of things. Okay, so let's get to the Golang, and I'm sure this is what you're here for. If you're a Golang developer, this is what you're here for. You're here for the backend. So here I'll just have a package folder. So I'll create a new folder called package, and I'll create a folder called Websocket. So Websocket instead of package. Okay. This is the reason why I didn't want to show this project early on in my YouTube journey, because we're going to be working with sockets. And then I'll have in the backend, I'll have a new file called main.go. And sockets is usually something that you usually learn when you have 3 to 4 months of experience with something, because otherwise a lot of people have trouble understanding how can things work in real time, how can there be sockets, how can you open TCP connection just like that and information can flow. And people get confused that, why do we even have CRUD APIs then? Why not just have everything with sockets, right? So this is why I recommend doing it like much later in your Golang journey. Okay, so in your main.go file, create package main. You must have also noticed that my actual high definition camera is not working today. It's because I'm using my old Ubuntu laptop, which is an Alienware laptop, and it somehow doesn't connect to my camera, so I'm having to rely on the webcam. In your package main, you'll be importing a couple of packages. So let me actually write the package that I want to import. So I want to import fmt package net/http package. So let me save it and see. Okay, so when I save it, it's not formatting the code for me. And it's also not removing these packages automatically for me. So if I was using some extensions, like out here, I can go and download some extensions, right? And in many of my projects, I do use extensions in VS Code, but I don't like using extensions. I don't use a lot of extensions when I am coding, right? But in my other projects, I've shown you how to use extensions with Golang. So when you save, it removes the packages that you're not using right now. I hope you can bear the fact that in this project series, I'm not using extensions. So you won't be seeing like really well formatted code, or you won't be seeing auto corrections and all those things. Okay. Just for this project, at least. I don't like using extensions anyways. I have to use it in very basic projects. I have to use it because beginner developers are very reliant on extensions. I am very comfortable making a lot of mistakes and then fixing them in post later on. So here in your func main, you want to print ln, the name, which will be here that Akhil's full stack chat project. Let's give it that name. And we want to create our routes. So set up routes. And we'll use the HTTP package that we have imported out here to say listen and serve. I'll start this on 9,000. Okay. So now, most importantly, you have to create the setup routes function, because that's what you're calling from the func main. Okay. So in case you're very, very new to Golang, and I don't recommend, if you're new to Golang, I don't recommend this project for you, but in case you are, then your main file is like the main file in your Golang, and your func main is like, where the control of the entire program enters from. So this is where the program first starts with, and this is why you call different functions from this function. So you have func, set of routes. So the setup routes function is going to first create a new WebSocket pool. So we'll have WebSocket.new pool. So this pool is going to be WebSocket.new pool. So new pool is going to be, sorry, not pool, new pool. So new pool is going to be a function in your WebSocket package. WebSocket package being this package here, package/WebSocket. So there will be multiple files in this package, and all of them will belong to the WebSocket package, because that's how the Golang naming convention works. If you have the name of the folder, and if you have files inside that, then all need to belong to the same package, which belong to that particular folder, which is like the same name as that particular folder. So here I want to have a couple of files. I want to have client.go, pool.go. Sorry, this is not a folder. This has to be a file. Okay, so here you create a new file, pool.go. Then you'll have your WebSocket.go file also here. So let's say WebSocket.go. And in your pool.go file, obviously there will be the new pool function that we're talking about. Okay. And in your main.go file, we'll also have to obviously import this WebSocket package. And how would we do that? We'll just say, we'll go to our Go mod, we'll pick up the name of our project. Right, so in Golang you have these kind of absolute routes. Put an absolute route here. And all you have to do is say /package/WebSocket. And Golang will get this package for you. So it's very easy to keep Golang code very modular. You divide them into packages. Each package can be a folder, and then all of these files belong to that same package. And you can import the entire package and all the functions inside that package very easily by step for an import. Okay. My pool will have a start function, so I can start a WebSocket really very easily. But I will be starting it as a Go routine. Okay, so when I use this Go keyword anywhere, it's saying that you want to start off a parallel process. Guys, in case you want some more detail about it, check out this video on my channel called Concurrency in Go in 5 minutes. Okay, very simple video. I've explained to you very properly. Go keyword, whenever you say, you're saying that in the main process, in the main flow of things, you don't want it to you don't want this to happen. You want it to happen in a separate flow, in a parallel flow, right? Which is not parallelism, it's actually concurrency. In a concurrent flow, you want to have it, so that if anything goes wrong with this flow, it does not really affect the main flow and does not block the main flow. Okay, so whenever you want to work with sockets, I usually prefer working in a separate process, in a separate Go routine. You don't have to do it. It's just the generally accepted practice to start it off in a concurrent process. Okay, do check out that video. You will have a lot of clarity. Now here I want to have a handle function, and the route is WS. The function will have W, which is a HTTP dot response writer, R, which is HTTP dot request writer. Just request, not request writer. And we'll call a function called serve WS, which obviously this is WS, so you want to serve WS. You want to pass it pool W. Now, when we use Golang as a web server and work in the web development side of things, you obviously need two things which are very fundamental, right? When working with the HTTP package. So HTTP package is generally used to work with things, with servers, right? Like request and response. So this is why you need request and response, because to a server you would always send a request with a struct or some data, JSON, whatever. And the response that you want coming out of that server will be basically a response, like a JSON response usually. Okay, so this is why with HTTP you'll often see these are like the building blocks when working with HTTP, like the extremely building blocks. So in my playlist, which has those 18, 19 Golang projects. The first few projects are just using HTTP package and nothing else. They're not using chai, they're not using chai or key or whatever you want to call it, CHI. They're not using Gojin, they're not using Fiber, they're just using HTTP, right? That's because this is like the core founding block of how to work with, like how to use Golang on the internet. Okay. So having said that, now you want to have obviously this function called serve WS somewhere here. So you'll say serve WS, and we know it takes three things. Suppose to take the pool, which is basically your Websocket.me pool. Right? This returns a pool to it. So here you'll say pool, and what is it? What is it? It's of type WebSocket dot pool. What does that mean? That basically means that pool, that we have defined pool on our own out here. Pool with a capital P. Okay, here that pool has a small p, which means this is a variable, but this capital P is a struct defined in the WebSocket package. So the WebSocket package, somewhere we'll have to define a struct called pool. Okay, so let me actually do that so that confusion goes away. So in your pool.go file, come here. Just define a struct. Now struct are your independent or customized data types that you can create. So Golang gives you some data types, but you can combine them in a different combinations and create your own data types with their own fields. So it can have a field like register, it can have a field like unregistered. This means on the socket you're registering, unregistering. You'll have clients, you'll have broadcast. So for register, now out here there could be strings or integers, right? In the sense they have to be these variables have to be of a type that Golang understands. So in this case they're channels. So register is a channel, unregistered is a channel. Clients. So clients is a map of clients and booleans. Okay, and broadcast is channel, and these channels are basically client. It's possible that you're wondering what is client, and why are we giving references to client. Client is actually going to be a struct out here. So let me do that so that there is no confusion. So usually when you see a capital letter preceding in a word, right, the first letter as capital, it's usually a struct. And obviously here, since register has to be of a type of something, right? It's channel, but it's of type client. So here you'll have client, which is a struct, but client will have just C capital, everything else is small. You'll have a struct will have ID, connection, pool, and mutex. String. Connection is of type WebSocket connection. And you have pool. Here you'll have sync.mutex. Now this WebSocket is actually a very famous from a very famous library or package, which is basically Gorilla. So Gorilla has Mux, Gorilla also has WebSockets. So here we'll say import not import github.com/gorilla/WebSocket. Okay, so even though we are working on the main.go file, and even though I wanted to cover this WebSocket package and new tool functions after a while, but I just thought, let me show you so that you understand where all of these things are coming from. So if I just write pool, something is of type pool, or something like that, which is basically out here, I've written WebSocket.pool, right? now I can say that this pool is going to be a struct that we'll create in a while, but then you start thinking ahead, you start getting confused. That's the problem with on YouTube. I'm not able to. That's the limitation of this format, that I'm not able to kind of keep your mind focused to where it should be right now, which is basically just focusing on something called a spool. But I understand that you might get confused thinking what is pools. This is why I showed you that pool is actually going to be a struct later on that we'll be creating. But I've created right now so that it's just clearer. And when I started writing pool, I realized that some of the things will be referring clients. That's why I created a client struct just to show you. Now, in many of the videos, I stick to what's happening presently, in the sense just this. And this is why many people kind of get a little impatient, thinking that, hey, now suddenly I'm not understanding anything, right? So it's not, when you're following a project like this, when you're building a project, it's not that every single second you have to understand what's happening in the project, right? When you've built when you've reached a milestone, when you look back, then you understand, okay, this is why I used it, this is why I didn't use it. That's how I like to teach. In the sense, the first few minutes, we won't talk about anything, we'll just code, but once you reach a milestone, then you'll understand, looking back, like, oh, this is now it makes sense. But what happens with this style of teaching, even though it's very efficient according to me, and I've used it on many people, so it's very efficient, but on YouTube, what happens is that people get really impatient, thinking that, okay, I understood it till 2 minutes 50 seconds, I understood that, but from then on, I'm not understanding anything. This is why I'm trying to explain everything to you now, what will be happening in the future, rather than focusing on what we're doing in the present. So apart from this pool, like the serve WS function also takes in W, which we already know is of type HTTP dot response right, and R, which is of type HTTP dot request. Okay. Hey guys, welcome back to the React and Golang full stack chat project cities. This is a real-time chat project. Now, we were creating a function called serve WS, right? Which is nothing but your Websocket, WS Websocket. And this is your Websocket endpoint. So when you hit the Websocket endpoint, this function is called. You're passing something called as Websocket pool to it, right? Pool. And Websocket.pool, we've already seen as a struct. Now, what happens inside this function is that you want to, at least if somebody hits this endpoint, you want to say WebSocket endpoint reached. Okay. Then, most importantly, you want to create a variable called connection, which is going to be WebSocket.upgrade. Now, just like we have new pool and things like that in our WebSocket package being this package in WebSocket. Similarly, we'll have something called as upgrade there. Upgrade, right? We'll talk about it in a minute. We'll talk about it. So just till then, just hold on. What you need to focus on is just getting this connection variable. Why do you want this connection variable? Because we have a client struct and we want to create a client here. To create that client, what we'll say is which client is equal to ampersand WebSocket dot client. What does that mean? We're simply referring the WebSocket client. We're referring the WebSocket client. Okay. And this has two variables. If you see, it has connection and it has pool. So what you want to do here is you want to have connection and you want to have pool. And how do you get the values of these? For connection, you will get this value, and for pool is basically being passed this function. So you'll have pool. Put commas so that it's formatted properly. You'll also handle this error out. So you'll say if error is not equal to nil, fmt.f printf w comma percentage plus v slash n and comma error. And what you want to do is you want to invoke or basically you want to write to this channel. So in your pool, you have these multiple channels, and we can write something in these channels, right? So in the register channel, whenever we create a new client, right? So whenever somebody hits the /ws endpoint, we're going to create a new client that is connected to the socket. And how is it connected? You connect it using con and pool. And here you want to use pool.register. And you want to write that too. After creating that client, you want to write it to the pool.register channel. And we'll read from client. Now when I say client.read, right, you would be kind of confused what is client.read. So does this remind you of something when you look at this? So read is definitely a function, but why are we saying client, which was the struct that we created here in client.go? Why are we saying client.read? So the thing is that read is not a function. It's going to actually be a struct method, a method that will be available for the struct client. And that's why you can access those struct methods by the struct client and the function name .read, the method name, sorry. So that means here in your client file, you'll have a method. So how do you write a method? How do you write a struct method? You write the struct here. So C, which is of type client struct. Okay, and the method name is read. And this is the same one that we're using out here, client.read. So that means something will go in this method as well. So in this read method, which is getting called out here when somebody hits the /ws or the WebSocket endpoint, at the end you're having, after you've registered that client, you want to read what's coming from that client. So you want to read what's coming from that client. That's very important, right? And at the end, what do you want to happen when something has been read from that client? What do you think should happen? You want to basically unregister that client, and you want to close that client. So first, let's talk about things that need to happen at the end. So how can you define something that should happen at the end? You can use defer for it. Yeah. So for defer function, that means this function will be called when this read function is happening or processing. This function is processing, and at the end of the call stack, that's where you want to call this function called defer function, called basically this anonymous function, right? Anonymous functions which don't have a name, basically they need to call themselves. That's why we put these two brackets there. So you want to have your pool, you want to have unregister, right? Where did it come from? Pool has register, we just registered in our main.go, and now we want to unregister it because we know that at the end of reading we want to unregister it. And in the unregistered pool you want to write C, write to the unregistered pool, and you want to close the connection. So it's connection dot close. All right. And what should really happen here? So Gorilla WebSocket, which is basically a connection here. So this connection variable is basically of type WebSocket.connection, right? This one. So this Gorilla WebSocket gives you access to something called as read message. So you'll access to c.con .read message. Now why C? Because C is basically your client and con is your connection string, a connection inside the client. And here you have c.con.read message. And you want to read multiple messages that are coming from here. So you'll put all of this in a for loop. Okay. So here you'll say message type comma p comma error c.con.read message.
First, let's handle this error. So we'll say if error is not equal to null, so log.println error, and okay, so that's about the error processing. But that's not the important thing. The important thing here is the message, because at the end, what you want to happen is you want to broadcast the message. So when somebody writes something, let's say, so this our channel should be able to read it and broadcast it. Broadcast the message. Okay. So I'll explain to you again. Broadcast the message. Message is something we've not defined yet. We'll have to define it. So we'll say function. Type message struct, and we'll have a type which is basically out here, message type that we're getting from read message, and it'll have a body. So it'll have like what type of message is it, and it'll have like a body. The body is the thing that we're interested in. Okay. So you say type int JSON type string JSON body. Nice. So what will you have here? You'll have message is equal to. So now you want to create message based on the message struct. So it needs to have two things, type and body. So for type, you'll obviously have this message type here because that's what you got back from it. So you'll say message type and body is string, which is p. And like I said, we'll be using our broadcast. So we'll say pool.broadcast channel. And how do you write anything on the channel? This is how you do it. You say message. So message has two things based on the message struct, which has type and body. Body is what we're really interested in. Okay. And we want to just broadcast that here, that message to the broadcast channel. So here we'll say print f message received percentage plus v comma message. Brought the project here so that I'll be able to finish it now. Okay, so while shifting the project, I'm not sure if I had done this before, but I have now created a go.mod file. I think I'd done it before also. So just to clarify, guys, there's a go.mod file. The name of my project is github.com/akhil/golang chat. So I've done this with go mod in it. And then I've done go mod tidy as well, so that it was able to get this Gorilla WebSocket package for me. So in case you haven't done that yet, and if your Gorilla WebSocket file, this import is giving a squiggly line or an error, please do that. And also if in your main.go file, if this is giving an error out here when you're trying to import this WebSocket package, then I suggest you run go mod init and go mod tidy together. Ensure that this is working perfectly fine before you proceed any further. Okay. All right. So now this file belongs to package WebSocket, and even this file. So all of these three files will belong to package WebSocket. Just WebSocket. So in your main.go file, when you're trying to call upgrade function and trying to call new pool function, all of these things, they are basically going to be coming from in one of these three files. So here also we'll say package WebSocket. Okay. And client.go file, I think it was almost complete, but this vsum looks a little wrong. So make sure you make it small v with percentage. I think I'd written this same thing somewhere else as well out here. Yeah. So in your main.go file also fix it. All right. So I don't think any more work is required in client.go. What we need to work with, however, is our pool.go file. So with our pool.go file, you have a pool which has register and register all these channels, clients, broadcast, and we started working on this new pool function. Okay, so let's go ahead and actually start building this function further. Your new pool function essentially is just going to return a new pool, and a new pool basically is going to have these four variables: register, unregistered, clients, and broadcast. So what you'll do is you'll say func new pool. What does it return? Like I said, it returns just a new pool. And whenever you're saying pool with a capital P, you're referring to this struct that you've defined here on top, and returns a reference to a new pool. Straightforward. Okay, and what does this have? Like I said, it's going to have all these four things. So we'll type it out. We'll say register, and to make a new channel, what do you say? You say make a new channel, and you say channel and start client. Okay, so channel start client. Here also you'll say make that channel. So you're just basically initializing the pool and creating a new pool and returning from this function. Unregistered will also do the same thing. Clients will also do the same thing. So if you have this autocomplete like me, it's very simple to type. And here also, you just select whatever the autocomplete throws at you. Just kidding. Just please check if this is matching, right? The map with client and pool is matching with, and channel message is matching with broadcast. Just make sure it does, everything matches. And then only proceed further, because sometimes even these autocorrects can be wrong. All right. Here is where create a function called start. Now it's just not just any function, it's a struct method actually. And so we'll say it will have access to pool, which is of type pool. So what does start function do? Here we'll run a for loop. It will select for case client, and we'll say pool.register. Okay. So we'll say pool.clients. Now pool.clients, we're referring to this out here. So pool is an instance of pool, which is this struct. And here you have multiple things. You have clients, register, unregister, all of those things. So one by one, we have to work on those. So we'll say clients. Is equal to true. And then we'll just print out the size of connection pool. Size of connection pool. Length pool.clients. So I'm not sure if I had shown you this in the demo of the product, but I'll show you once we complete it. I'll show you on the demo. What's supposed to happen is that we'll have multiple concurrent connections. This is how connection pools work. So we're not just having chat between two people. We can have multiple people in that chat room. And to do this, we need to create a connection pool. To create a connection pool, what we're saying is that how many number of clients are there. We want to basically print that out in our terminal, because there could be the more browsers that you open up, individual browsers that you open up, and all pointing to obviously localhost 3000, the more number of clients that you will have, and all of those clients will be available on this connection pool, and we're basically creating a chat room which doesn't really have a limit on the number of clients it can have. So that's why when you want to see how many clients are there, you'll say you want to find out the size of the connection pool, and you just print out the length of the pool. You already know it's a struct and it has multiple clients. It's a map with clients, so it'll print out the number of clients. And here we'll say for client, and we'll range over all the clients. And we'll print out the client. So every single client that we have, we'll print it out. And whenever a new user joins, right, to the entire connection pool, all of the users who are there we want to send something like, hey, a new user has joined, something like that we want to send. So what we'll say is we'll send a JSON message, because our React frontend can read JSON very easily and print it out. So here we'll say type 1 body is new user joined. Just type 1. Okay. After here you'll say break. And whenever a new user joins, we're calling that as register pool. Obviously, that's why we have created this channel. Whenever new clients join in, we print them out, or register them in the register pool. And then we have our other case, which is pool.unregister. What do you want to do here? So here you want to delete from the pool of clients the particular client who wants to unregister. So you have multiple browsers open up, and as soon as one more person joins up, everybody gets a message saying new user joined, and we'll print out the size of the connection pool whenever somebody registers. But whenever somebody unregisters, what you want to say is you want to delete that particular client. And what I mean by unregistering is that somebody's just closing off their browser, then you're just unregistering that client from the pool. Okay, so that particular client has been registered from the pool of clients. And again, you'll say the size of connection pool. So you'll copy and you'll paste it here. And then you'll go again, for all of the clients. So copy and paste this. And say client dot connection, this whole thing, copy and paste it here. And say user disconnected. Okay, so we're just advertising to everybody that, hey, this guy has one user disconnected. And then you break. And then you have somebody writing a message, so you would want to broadcast it. You'll say pool.broadcast, and you'll say fmt.println sending message to all clients in the pool. And here you will say for client, again the same thing. We're just going to range over all the clients again. So we'll say range pool.clients client.connection.write JSON. So the same thing, only instead of writing a custom message, we're actually just going to pass the actual message. And you'll say error is not equal to nil. fmt dot println error, and you return. Okay. So that's it. You don't have any errors in this file. Everything works perfectly fine. To me, everything looks okay. Client.go also looks okay. Yeah. So now it's time to work on our Websocket file. All right, so in your Websocket file, websocket.go file, what you'll say here is you'll import log, you'll import net/http, and you'll import github.com/gorilla/websocket. Then we're going to have a function called upgrade. So as you can see here, there's a function called upgrade. We'll have to create that here. So we'll say func upgrade. It's going to take W and R. W will be HTTP.response writer and R will be HTTP request. What does it return? It returns a WebSocket connection or an error. So we'll define a variable called upgrader. And it's of type WebSocket, which is from this file, from this package .upgrader. And we'll have a read buffer size as 1024 and write buffer size as 1024. Now the place where I am getting this code from is the Gorilla/WebSocket package. So here you see that this is the exact code that they've given us here. What they're saying here is that the connection type represents a WebSocket connection, and basically you call the upgrader function to get back the connection, the start connection. So in our code, we're doing exactly the same thing. We want WebSocket connection, and then we'll have to call the upgrader for it. So the function upgrade not only calls the upgrader, which is the upgrader.upgrade function, which we'll have to call in a while, but we'll also have to have some origin considerations. Okay, so we want if there are multiple browsers, we want them to represented as multiple clients, and that's why we'll have to do some origin checking as well. So what we'll do here is we'll come here and we'll say upgrader.check origin function r/start HTTP request boolean return true, and upgrader dot upgrade. Always keep the documentation open at your side so that you can pick up code from there. And here you'll say if error is not equal to nil. Actually, the benefit that you get with opening documentation is you can just pick up code and put it there directly in your code. You don't have to make any changes, because what you see here in these documentations is like properly tested code, right? So it saves a lot of time. This is what I always do. Always, like, I'll just copy and paste a lot of this stuff. Saves a lot of time. You know, because these are really experienced guys who have written this documentation and who have made those packages. So just rely on their expertise. Okay, so you'll print out the error and then you'll say return nil comma error, and here you'll say return connection comma nil, because connection WebSocket.connection, according to the documentation that we just read, is what we want to be returning. Log is a package it will get in automatically. All right, so everything in the backend looks all right, other than this pool, start pool. I don't know why it's creating an issue. Let's check it out. Now the code editor is telling me there's an issue here, there's an error here, but I have checked everything and it doesn't look like an error to me. And this is a common problem when you use these extensions. Sometimes Golang tells you there's an error where there's not supposed to be any, because I want exactly this. I want this pool to represent the pool struct that I've defined, which is out here. This is exactly what I want. So what I will do is I will just go ahead and I will run. I'll say go run main.go. And here you can see the chat project works perfectly fine. It's not giving me any issues in the terminal. So what I'll do now is I'll check out the front end as well, and then let's do a complete test. Even though there's an error here, there's no error in the backend. There's nothing in the terminal, no issues. So backend was working perfectly, and now I have opened up another terminal for my front end, and here I'm going to go ahead and say npm start. Okay, so there is some error. All right, so I'm getting this error because I'm using Node 17.4. I'll have to downgrade it. I saw that this issue happens with this latest version of Node.js. I'm using NVM, so I'll say NVM use 12.13 for now. You could use 14 and 16, it would work perfectly fine. I'm using 12.13 now. And here we'll say npm start. That should work properly. So as you can see here, it's starting up on localhost 3000. And just as we wanted, it's saying new user joined. I'll go ahead and type something. Perfect. And now I'll open up a new browser. And in this new browser, I'll again hit localhost 3000. And again, it says new user joined. And if I write something, Akhil hello, this message I should be able to see on my old browser. As you can see here, it says Akhil hello, right? So, hey Robert, if I write that here, I'll be able to see that there, hey Robert. Awesome, right? So two people are able to chat between themselves. Similarly, if I add one more browser here and I say localhost 3000, it says new user joined, and out here for all the two guys before in the other browsers, it says new user joined to them as well. It's updating them here as well, new user joined, right? So everybody will be able to chat with each other. So this is the power of connection pools. Now I may have changed the front end a little bit, in the sense I did see a small issue here and there. Let me tell you what I'm talking about. So when I open up my front end, when I was going through my front end, I saw that in some of the components and the index file, I had not kept this as capital, right, to include the name of the component. In some of these, it was a small character. So I have changed this around. In case your front end is not working, just make sure you check the components properly. And I'm leaving this code now on GitHub. I'll give you the link in the description box of this video. So go ahead and first compare it with my code, and then you see if it's working or not. But mostly this is where you'll find the issue to be. So when I was going through the code, I changed these quickly, right? This is not an error, it's just a silly mistake, small silly mistake, because the name of the component has to be there. And do compare your code with this, and yours will also work perfectly fine, just like this. And I hope you liked this series a lot. You learned quite a bit. I know it took me a long time to finish it, but that's how it is. You know, I had so much other work going on. My laptop was not working, which had this project, so I had to extract it somehow and put it here to get it to work, and then finish it. All right, guys. So do subscribe to the channel if you haven't already, and I'll see you in the next video or in the next series. So this series has now come to an end. All right, see you.